Hi guys, so this is what's known as a quadratic inequality. It's something that students of algebra struggle with quite often, but we'll go through it step by step, explaining every step, and by the end of this video you'll know this cold. But before I continue, I should introduce myself. My name is John, and I tutor and teach math at all levels. You can get the help you need, whether it's middle school, high school, or college level math. I've been tutoring and teaching it for over 20 years. I have a PhD in math, and I'm dedicated to making the most difficult math topics very, very clear. So if you're looking for help, or you just want to review basic topics, or you're struggling in a particular class, follow the link in the description. So how do we solve this quadratic inequality? We'll first solve the corresponding quadratic equation, meaning we'll replace the less than or equal sign with an equal sign. And this is a simpler quadratic equation. The standard way to solve this is by factoring the trinomial as a product of two binomials. Trinomial meaning it's three terms, as in tricycle. And we factor it as a product of binomials, meaning each of them have two terms. The terms are simply the items we're adding and subtracting. So this is a product of x plus something times x plus something. And there's a little bit of guesswork to get it. We want two integers whose product is minus 5 and that add to minus 4. But there are only two that work, and that's minus 5 and 1. We can in fact check that this works by using the FOIL method. FOIL stands for first, outside, inside, and last. For the first, we take the product of the first two terms in each binomial, x times x, which we just write as x squared. For the outside, we take the outer terms, x and 1, and multiply them, and that's just 1x. We add in the product of the inner terms, and that's what the inside stands for. That is minus 5 times x. And then finally, the last two terms in the binomials, minus 5 times 1, which is minus 5. We can then combine like terms, meaning x and minus 5x are like terms, and x minus 5x is minus 4x. And in fact, we get our original trinomial, so that checks out. Now we can apply the zero product property. That is, if the product of two numbers is 0, one or the other, or both, must be 0. So we get that either x minus 5 is 0, or x plus 1 is 0, or both. We then solve each of these two equations, giving us either x is 5 or x is minus 1. This means that the function can only cross the x-axis in two places, minus 1 and 5. Think of it as a river, and we're either north or south of the river, and we can only cross it at two places, two bridges. We need to know exactly when we're south of the river, and that will give us our solutions. So we'll pick a test value in between minus 1 and 5. An easy one is 0. We find that f of 0 is minus 5, so it's negative, because we can't cross the river any other place. So in between minus 1 and 5, we must be south of the river. Next, we pick some values to the left of minus 1 and to the right of 5. We'll just pick minus 2 and 6. We see that f of minus 2, that is the polynomial evaluated at minus 2, is positive. So we're north of the river. And also f of 6, which is the polynomial evaluated at 6, is also positive. So we're north of the river there. Since the function is positive at minus 2, it's got to be positive at all points less than minus 1, because we can't cross left of minus 1. And also it's positive at all points greater than 5. So our solution has to be all numbers in between minus 1 and 5, including the endpoints. And we write that as the closed interval from minus 1 to 5. And this is the graph of the function complements of Desmos. You can see that the solution we found is represented by the blue line. Thanks for watching, and I'll see you again.